Welcome back. This is now station 3. Water is a superstar. We are looking for what are some properties of water. Specifically, we're looking at the hydrogen bonding or surface tension. We are looking at phase changes, and we are looking at the water cycle. We will start with preparing our ice cube. We will start with, and always talk about, when you're talking about water, we're going to talk about the phases. Oh dear, what can the matter be, solid or liquid or gas? And the gas is referring to the water vapor out in the air. And we're going to ask the students if they can walk an ice cube. We're going to go ahead and attach the string, allow students to attach the string to the ice cube and ask them to pull it. They'll do this several times, it won't work. Make sure your string is slightly frayed. Lay it across the ice cube, and then you will pour a generous amount of salt over the top of the ice cube. Salt and most solutes will go ahead and decrease the freezing point, meaning it will melt, because it has to be a lot colder for it to freeze. This is why we put our salt on the sidewalks. After time has elapsed, it will refreeze, and you will be able to pull that ice cube because it is refrozen around the string. Oh, excuse me, too much time has elapsed in this case. But by the time you're halfway through the demo, this will be prepared for you. The next phase we will do is we will take a glass that appears to be full, and we will take our micro pipette. Don't take the water back out of the glass. Make sure you have another source, otherwise you're just returning the same water to the glass. And drop by drop, keep asking the students if the glass is full. Eventually you will have a bubble over the top, and let the students guess when that bubble will break. The table needs to be still. It will be important that none of the children are bumping the table. And eventually they will have the chance. Ask them to please come down at eye level and view. I will need a great deal more water in here. And then in the end, go ahead and allow it over the top. And you will start to see water over the surface of the edge. And is able to do this through hydrogen bonding. The water is 2 hydrogen and 1 oxygen bonded together. There's some uneven sharing of the electrons. It allows for them to act like magnets, and they will hold on to one another, allowing the water to hold to itself. That's how we have round droplets. It is how the water is able to cling to itself. So you can see that over the surface. With this same idea in mind, the students will each be able to take a pipette, and they will have a competition of how many droplets their pennies can hold. And now we'll do. And they can count. Now there will be 3 pennies at each station, 9 children, so 1 dropper, 2 counters at each station. They will have a competition. It will form this because of hydrogen bonding, and eventually it will break. Whoever has the most droplets, of course, on their penny wins. A steady hand will allow you to put many more, and eventually the power of gravity will overcome the hydrogen bonding and the bubble will burst. Next, we're going to again look at the hydrogen bonding or surface tension. We will go ahead and we will take a little bit of pepper and sprinkle it over the surface of our water. The water is held by hydrogen bonding across the surface. It's also what allows the water striders to swim on top of the water. Those little bugs that you see out on calm rivers or ponds skimming across the surface of the water. It is holding the pepper in place. And then you just need 1 single drop of liquid dish soap, 1 drop of water, because soap has a hydrophobic and a hydrophilic end. It will break that polar bond between the molecules, and you will see the pepper quickly. 1 single drop. Oh, excuse me, it did not. So much for that one. We'll try that again. Okay, next one is our power boat. I think I needed to have black pepper, not red pepper. I they didn't wash these, maybe they still had soap in them. Here goes our power boat, and we have a single scoop of, and this is laundry detergent, and the laundry detergent will power the boat. As it breaks the surface tension, it will move the boat forward. Allow that boat to move. The last thing we will do is create a water cycle. It is important that your assistant that is with you have this ready for you. We will have hot water ready. Again, in front of you are all the phases of water: solid, liquid, and gas. And steam is great because you can see the water as a gas. A great time again to sing our song. Oh dear, what can the matter be, solid or liquid or gas? And then you can go ahead and hold your ice on top. Be careful if you have very, very hot water so that the kids don't. And what you're going to see here is now we have the liquid water. It is turning into steam, which is evaporation. And then we're looking for it to condense back on our ice pack, and then for it to precipitate. This may take a little bit of time. So it might be a one where they can go ahead and start working on their coloring pages as this is starting to form. But you can start to see the moisture forming, so it can fall back. This might be a better one. If you want more pop, it's not quite as accurate, but it can cause the ice cube to melt. This may be a better solution. You can go ahead and allow this will be a quicker fix. Maybe grab one of your ice cubes. And in this case, it's not truly condensation. The heat is actually melting the ice, but hopefully it will allow them to at least see the process of the liquid water evaporating as steam or water vapor, and then we're going to say it's condensing on the ice cube and then precipitating back down into the water. Good luck!